Today we're diving into the fascinating world of solar flares and their impact on Earth. The sun is far from a static object in the sky. It's a dynamic and often volatile celestial body. These bursts of energy are what we call solar flares. Imagine a billion atomic bombs detonating simultaneously. These flares send waves of radiation and charged particles across space. Our planet's magnetic field deflects these charged particles, but powerful flares can disrupt communication systems and create stunning auroras. Our story begins in 1859, a time when our understanding of the sun was still in its infancy. On September 1st, the sun unleashed the most powerful solar storm ever recorded, the Carrington event. Richard Carrington, an amateur astronomer, observed two brilliant white lights erupt within a group of sunspots. Within hours, the effects rippled across the globe, telegraph systems went haywire, operators received shocks, and auroras were sighted as far south as Cuba and Hawaii. Imagine the awe and terror those auroras inspired. The Carrington event serves as a stark reminder of the raw power of our sun. Now you might be thinking, telegraphs? Who cares about telegraphs? But in 1859, the telegraph was the cutting edge of communication technology. It was the internet of its day, connecting people across continents in ways that were previously unimaginable. So when the Carrington event hit, it wasn't just a scientific curiosity, it was a major disruption to global communication. Imagine for a moment, a world without internet, without cell phones, without satellites. That was the reality of 1859, and the telegraph was the lifeline that kept information flowing. But as the charged particles from the solar storm bombarded Earth, they induced powerful currents in the telegraph wires, overwhelming the system. Sparks flew from telegraph equipment, setting fires in some instances. Telegraph operators reported receiving painful electric shocks just by touching their equipment. Some operators even found that they could disconnect their batteries and send messages using only the geomagnetically induced current from the storm. Talk about turning lemons into lemonade. The disruption to the telegraph system during the Carrington event highlighted the vulnerability of our technology to the whims of space weather. It was a stark lesson that even in a world less reliant on technology than ours, the sun's fury could have a significant impact. The Carrington event's most stunning aspect was the global appearance of auroras, or northern and southern lights. Typically, auroras are confined to high-latitude regions near the Earth's poles, but during the Carrington event, they were seen as far south as the Caribbean and near the equator. Imagine stepping outside and witnessing the sky ablaze with vibrant hues of green, red, and purple. It must have been a truly awe-inspiring sight. Fast forward to 1921. The Roaring Twenties, a time of flapper dresses and jazz music. But the sun reminded us of its power. In May, a powerful solar storm struck Earth, known as the New York Railroad Storm. It was the most severe geomagnetic storm of the century. Telegraph lines went haywire and electrical systems failed. The storm highlighted our dependence on technology. Lights flickered and died, plunging the city into darkness. Streetcars halted and the air crackled with energy. This was the reality of the 1921 solar storm, a wake-up call to our reliance on electricity. The sun's activity could disrupt our lives significantly. As our technological dependence grows, so does our vulnerability to space weather events. Now let's delve into the science behind the chaos. The 1921 storm was particularly potent because it triggered intense geomagnetic disturbances. Remember Earth's magnetic field, our protective shield? Well, when a solar storm hits, it can cause the magnetic field to fluctuate rapidly, creating what we call a geomagnetic storm. These geomagnetic storms can induce powerful electrical currents in long conductors, like power lines and telegraph wires. It's like plugging a tiny wire into a massive power source. The surge of energy is simply too much for the system to handle. And in 1921, those induced currents had a dramatic impact. In New York City, the storm caused widespread power outages, plunging the city into darkness. Telegraph systems, still recovering from the Carrington event, once again went haywire, disrupting communication networks. The 1921 storm served as a stark reminder that the Earth is not isolated from the cosmos. We are, in a very real sense, connected to the sun and its activity. And as we continue to rely more and more on technology, understanding and mitigating the risks posed by space weather becomes increasingly crucial. Perhaps the most dramatic consequence of the 1921 storm was the outbreak of fires in railroad control rooms. Remember those induced currents we talked about? Well, in some instances, these currents were so strong that they overloaded electrical equipment, causing them to overheat and ignite. Imagine the scene. You're a railroad operator going about your day, when suddenly sparks begin to fly from the control panel. Smoke fills the air as electrical components burst into flames. It must have been a terrifying experience. These fires, while relatively isolated, highlighted the potential danger that geomagnetic storms pose to critical infrastructure. The railroad system, a vital artery of transportation and commerce, was brought to its knees by the sun's fury. It was a stark reminder that even our most advanced technologies were vulnerable to the whims of space weather. The 1921 New York Railroad storm, with its fires, power outages, and communication disruptions, served as a turning point in our understanding of the Sun-Earth connection. It forced us to acknowledge that the sun was not just a distant star, but a powerful force that could directly impact our lives and our technology. The year was 1989. The Cold War was thawing, Milli Vanilli was topping the charts, though we wouldn't know about their lip-syncing scandal just yet, and the world was about to get a crash course in the raw power of the sun. In March of that year, a severe geomagnetic storm struck Earth, and it wasn't messing around. Now, you might be thinking, a geomagnetic storm? Sounds intense. And you know what? You'd be right. These storms are like solar hurricanes, bursts of energy from the sun that interact with Earth's magnetic field. And this one? Well, it packed a punch. It all started with a massive solar flare, an eruption of radiation from the sun's surface. This flare hurled a wave of charged particles toward Earth, and when these particles hit our atmosphere, they triggered a spectacular light show. Auroras blazed across the sky, visible as far south as Florida. But it wasn't all pretty lights and wonder. The storm also wreaked havoc on our technological systems, reminding us that for all our progress, we're still at the mercy of cosmic forces far greater than ourselves. One of the most dramatic impacts of this storm unfolded in Quebec, Canada. Imagine this. It's just past 3 a.m. People are sound asleep, when suddenly, everything goes dark. 9 million people plunged into darkness. What caused this sudden blackout? You guessed it, the geomagnetic storm. The storm's charged particles interfered with the electric currents flowing through Quebec's power grid. Think about it like this. It's like a surge of electricity going through a wire that's not designed to handle it. Chaos ensues. This wasn't just a minor inconvenience, it was a major wake-up call about the vulnerability of our power grids to these solar outbursts. The blackout lasted for 9 long hours, bringing life in Quebec to a standstill. Schools and businesses were shut down, transportation systems were disrupted, and the economic losses were substantial. But amidst the chaos, there was a silver lining. The Quebec blackout served as a harsh but valuable lesson about the importance of space weather preparedness. The March 1989 geomagnetic storm wasn't just a regional event, though. Satellites in orbit around Earth were also hit hard. Some experienced electrical failures, others tumbled out of control, and a few even went completely offline. It was a stark reminder that our space-based infrastructure, so critical for communication and navigation, is also vulnerable to the sun's temper tantrums. The storm also disrupted radio communications, creating static and interference that made it difficult for ships, airplanes, and even emergency services to communicate effectively. Imagine trying to land a plane or coordinate a rescue mission with spotty radio contact. Not a good situation, to say the least. The 1989 storm was a stark reminder that the sun is not always our benevolent neighbor. It's a dynamic star, capable of unleashing powerful forces that can disrupt our technological way of life. But it was also a call to action, a wake-up call for governments, scientists, and engineers around the world to work together and develop strategies to protect our planet from the next big solar storm. Fast forward to 2003. Just as Halloween rolled around, bringing with it costumes, candy, and spooky tales, the sun decided to get in on the act. But instead of tricks and treats, it delivered a series of powerful solar flares that left scientists and engineers both awestruck and a little terrified. From late October to early November, the sun unleashed a barrage of solar flares, some of the most intense ever recorded. These flares weren't just bursts of light, They were powerful eruptions of energy that sent waves of charged particles hurtling through space at incredible speeds. It was like a cosmic fireworks display, only instead of oohs and ahs, it elicited gasps and nervous glances. Now these solar storms weren't messing around. One of the most powerful flares, clocking in at X28, that's X as in extreme, my friends, saturated the sensors used to measure solar activity. Imagine trying to measure a tsunami with a rain gauge. That's how off the charts this flare was. As these solar storms slammed into Earth's magnetic field, they triggered some of the most spectacular auroral displays in recent history. Normally, you have to be pretty far north or south to catch a glimpse of the northern or southern lights, but during these storms, the auroras were visible much farther from the poles than usual. People across the globe, from the United States to Europe to Australia, were treated to dazzling displays of green, red, and purple light dancing across the night sky. It was like a celestial light show, a reminder of the awe-inspiring power of the cosmos. But amidst the beauty, there was also a sense of unease, a reminder that these beautiful auroras were a visible manifestation of powerful forces capable of disrupting our technological world, and disrupt they did. The Halloween storms wreaked havoc on satellites, causing malfunctions, communication outages, and even forcing some spacecraft to temporarily shut down to avoid damage. Imagine your GPS suddenly going haywire, or your satellite TV going out in the middle of your favorite show. Not exactly ideal, right? But the impacts weren't limited to space. The Halloween storms also disrupted GPS signals here on Earth, causing inaccuracies that affected everything from navigation systems to surveying equipment. Airlines had to reroute flights, and some even grounded their planes entirely to avoid potential communication problems. The storms also caused radio blackouts, interfering with communication systems used by airlines, emergency services, and even amateur radio operators. It was a stark reminder of how reliant we've become on technology and how vulnerable that technology is to the whims of the cosmos. The Halloween 2003 solar storms were a wake-up call, a reminder that even in the 21st century we are still very much at the mercy of the sun. They highlighted the importance of understanding and predicting space weather and the need to develop strategies to mitigate the impacts of these powerful solar events. After all, when it comes to the sun, we're not just stargazing, we're staring down the barrel of a cosmic cannon. Now let's fast forward to 2012. Remember that time everyone thought the world was going to end? A solar flare that year almost made those doomsday prophecies feel real. Luckily, this monster storm missed Earth. It was like aiming for a bullseye and hitting the wall. This storm packed enough energy to power the US for 520 million years. That's a planetary reset button. Imagine auroras dancing in Florida, widespread outages, fried satellites, and dark communication systems. This event underscored the importance of predicting solar storms. So, what exactly happened in 2012? On July 23rd, the Sun threw a cosmic temper tantrum. A massive coronal mass ejection, or CME, erupted aimed at Earth's orbital path. A CME is a billion-ton cloud of superheated plasma traveling at millions of miles per hour. Luckily, Earth had already passed that point in its orbit. It was like dodging a speeding bullet. Had this CME erupted a week earlier, it would have been a direct hit. The 2012 near miss was a wake-up call. Even a glancing blow from a major solar storm could have devastating consequences. Imagine a world without GPS, internet, or electricity. The 2012 event spurred a renewed focus on space weather prediction and mitigation. The 2012 solar storm, though a near miss, served as a stark reminder of the power of the sun and the vulnerability of our planet. It highlighted the importance of space weather forecasting and the need to develop strategies to mitigate the impact of future solar storms. Think of it as a cosmic shot across the bow, a reminder that we are sailing on a ship through a sea of stars. This event spurred a flurry of activity in the scientific community. They developed new models to predict future solar storms and began working on ways to protect our critical infrastructure. Space agencies around the world realized that solar storms are a global threat and began sharing data and resources. The 2012 event may have been a near miss, but it was a wake-up call. The year is 2017. Things are relatively quiet on the cosmic front. In early September, the sun unleashed two powerful solar flares. These were X-class flares, the most intense eruptions. The first flare erupted on September 6th, followed by an even more powerful flare on September 10th. The first flare caused a radio blackout, disrupting communications. You might think, radio blackouts? Not my problem. But solar flares impact more than just radio. They disrupt GPS, which relies on precise satellite signals. Flares hit the ionosphere, causing GPS errors. Imagine your GPS telling you to U-turn on a highway, or a pilot getting inaccurate readings in bad weather. 2017 flares were short-lived, but a reminder. We need resilient systems and backup plans. So, we've talked about the flares, but these solar outbursts often come with a side dish, and this side dish is a doozy. I'm talking about coronal mass ejections, or CMEs. Remember those billion-ton clouds of plasma we discussed earlier? Well, the 2017 flares didn't disappoint. They hurled multiple CMEs towards Earth, adding another layer of complexity to this solar spectacle. Now, CMEs are fascinating. They're essentially giant magnetic bubbles of plasma ejected from the sun's atmosphere. When they reach Earth, they interact with our planet's magnetic field, creating a geomagnetic storm. Think of it as a cosmic tug-of-war between the sun's magnetic field and Earth's magnetic field. These geomagnetic storms can have a range of effects, from the beautiful to the disruptive. On the one hand, they can trigger stunning auroral displays, those mesmerizing curtains of light dancing across the night sky. On the other hand, they can disrupt power grids, knock out satellites, and interfere with radio communications. The 2017 CMEs fortunately didn't cause any major disruptions to our infrastructure, but they did trigger some spectacular auroral displays, visible even at lower latitudes than usual. So, while these solar events can be disruptive, they also remind us of the interconnectedness of our solar system and the awe-inspiring beauty of the universe we inhabit. As we've explored the impact of solar flares on Earth, from the historic Carrington event to the near miss of 2012, one thing becomes abundantly clear. We are living in a dynamic and interconnected solar system. The sun, while the source of life and energy for our planet, can also unleash forces capable of disrupting our technological civilization. Understanding and predicting these solar events is not just an academic exercise. It's crucial for protecting our modern infrastructure, from power grids to communication systems to the satellites that guide our way. Just imagine a world without GPS, internet, or even reliable electricity. It's a stark reminder of how vulnerable we are to the whims of our nearest star. But amidst the potential peril, there's also a sense of wonder. These solar events remind us of the immense power of the universe we inhabit, a universe filled with both beauty and danger. The stunning auroral displays triggered by geomagnetic storms are a testament to the awe-inspiring forces at play in our cosmic backyard. So the next time you see a news report about a solar flare, don't just scroll past it. Take a moment to appreciate the power of our sun, the interconnectedness of our solar system, and the importance of continued scientific exploration and technological innovation in safeguarding our planet from the occasional cosmic tantrum.